This is Chapter 5, Lesson 8, Factor Linear Expressions. So I can find the GCF of monomials. A blank is a number, a variable, or a product of a number and one or more variables. In that blank, you're going to write monomial. Okay, so a monomial is a number, a variable, or a product of a number and one or more variables. So we have a couple of examples. A monomial could be 25, it's just a number, x, just a variable, or 40x, so that's a product of a number and one or more variables. Okay. X plus 4 is not a monomial, so it has that plus sign in the middle, so it's not a monomial. 40x plus 2, again, there's a plus sign. 40x plus 120, again, not a monomial. So, to blank a number means to write it as a product of its factors. Okay, so in that first blank, you're going to write factor. So to factor a number means to write it as a product of its factors. A monomial can be factored using the same method you would use to factor a number. The blank GCF of two monomials is the greatest monomial that is a factor of both. So in those three blanks, you're going to write greatest common factor. So the greatest common factor, or GCF, of two monomials is the greatest monomial that is a factor of both. Okay, so let's take a look at an example. First thing I want to do is find the GCF of each pair of monomials. So I have 12 CD and 36 CD. So the first thing that I want to look at is I want to take 12 and I want to break it down into its factors. So factors of 12 are 2 times 2 times 3, because 2 times 2 is 4, 4 times 3 gives me 12. So I wanted to break it down into its prime factors. So 2 times 2 times 3 times C times D. 36 CD broken down into prime factors is 2 times 2 times 3 times 3 times C times D. Okay. Then what I can do is I can look and see what they have in common. Well, they both have a 2 in common. They both have another 2 in common. They both have a 3 in common, a C in common, and a D in common. Okay, so I'm going to take those 2 times 2 times 3 times C times D. So the GCF of 12 CD and 36 CD is 2 times 2 times 3 times C times D, or 12 CD. Okay, so that's what I was doing for that. All right. So the other thing I want to talk about is factoring linear expressions. You can use the distributive property and the work backward strategy to express a linear expression as a product of its factors. A linear expression is in blank blank when it is expressed as the product of its factors. In those two blanks, you're going to write factored form. So it's in factored form when it's expressed as a product of its factors. So I have 8x plus 4y, okay? And each of those numbers, I can take something out. I can take 4 out of 8x, and I can take 4 out of y. That's the GCF, that's the thing that they have in common. So when I do that, I put 4 on the outside, and I'm left with what's on the inside of my parentheses, 2x plus y. Okay. So let's take a look at an example of this. So I want to factor 3x plus 9. So you can either use a model or use the GCF. So the first thing I'm going to look at is using a model. Okay, when I do that, I have 3x plus 9, so I draw 3 x's, and then I break 9 down into 3 rows with 3 in them each. Okay, so I can arrange 3 x tiles and 9 1 tiles into equal rows and columns. The rectangle has a width of 3 1 tiles, or 3, and a length of 1 x tile and 3 1 tiles, or x plus 3. So I have 3 rows of these, and each row makes up 1x plus 3 1s. Okay. I can also use a GCF. So method 2 is using a GCF. 3x is broken down into 3 times x, and 9 equals 3 times 3. So they both have a 3 in common, which is what I take out. So my GCF is 3, and I'm left with x plus 3. So either way, my factored form is going to be 3 times the quantity x plus 3. A garden has a total area of 15x plus 18 square feet. Find possible dimensions of the garden. So 15x equals 3 times 5 times x, and 18 is 2 times 3 times 3. Well, they both have a 3 in common. So 3 is my GCF. So the GCF of 15x and 18 is 3. Write each term as a product of the GCF and its remaining factors. So 15x plus 18 equals 3, and what I have left here is 5x, and then what I have left with the 18 is 6. 2 times 3 gives me 6. So I can take out the 3, and I'm left with 5x plus 6. So the possible dimensions are 3 feet by 5x plus 6 feet. All right, there are a couple of try problems, so I want you to go ahead, pause the video, try them out, and then we will go over the answers together. All right, now that you've had a chance to look over the questions, let's go over the answers together. The first try problem says find the GCF of the pair of monomials 25x and 15xy. Okay. 25 can be broken down into 5 times 5 times x. 15xy can be broken down into 3 times 5 times x times y. So 25x equals 5 times 5 times x. 15xy equals 3 times 5 times x times y. Well, they both have a 5 in common, and they both have the x in common. So this one I'm left with 5, and this one I'm left with 3y. So my GCF, I took a 5 out, and I took the x out, so my GCF is 5x. My second example says, factor the expression 3x plus 33y. If the expression cannot be factored, write cannot be factored. Okay? So I want to figure out what I can take out of both 3x and 33y. Well, 3x is 3 times x. 33y is 3 times 11 times y. They both have a 3 in common. So 3 comes out, and up here I'm left with x plus 3, and here I'm left with 11y. So my factored form is 3. You can see they both have the 3. X plus 11y. My third try it problem says factor the expression 4x plus 35. If the expression cannot be factored, write cannot be factored. 4x equals 4 times x, or 2 times 2 times x. 35 is 5 times 7. There's nothing here in common, so this can not be factored because they have nothing in common. Okay. So number 3 cannot be factored. If you tried to put this in using models, you would not get a rectangle, which also shows that it cannot be factored. Okay. That is the end of lesson 8.